So thanks everyone for coming. It's a pleasure to be here and talk. So I'm going to be talking about how using SaltStack together with deploying containers, basically. I'm going to start to talk a bit about Bloglovin, since they are the one paying for my tickets here. I am actually based out of Stockholm, Sweden. Our headquarters are in New York. We're a small startup, but we got quite a lot of traffic. So we have tens of millions of active users each month. We have 100 million requests per day. And we are running everything out of Stockholm, Sweden in our own data center, and we have some services via AWS. So Bloglovin is a RSS reader, basically. It's an RSS reader that doesn't look like an RSS reader. So our typical users is female, around 25 years, looking for good content. So we are scraping the web, pulling all the RSS feeds into our systems. We're parsing around a couple of million stories per day in our own data center. And we are 1.5 guy ops team, which is me and the other devs in the team, which can be frustrating at least. So today I'm going to be talking about all of these buzzwords, so configuration management, containers, all of the stuff that are cool and that you always try to have time to play around on the side. We actually been running these kind of stuffs in production or containers for about a year or last summer. I've been playing around with Salt and Docker quite a lot. It has evolved over the time. When we started last summer, there were a lot of bugs in the Salt implementation or the Docker P module. So why are we going for containers? I'm going to start to give like a background of how we do stuff at Bloglovin and what is kind of the reason to go with Salt and Docker. So of course, everybody knows about it. It's the build, ship and run everywhere. But it's really neat. You can actually make it transferable. You have all your dependencies in one kind of box. You just put it anywhere and you can run it. But it's actually really hard in production. You will get a lot of things that fails. It could be application-wise. It could be file system-wise. How do you run it? How do you get containers to talk to each other? All that stuff. It's really not worked out yet. There are, of course, a lot of people trying to solve this, a lot of tooling out there. But most tooling that are coming up right now, I think it's like one new tool every day. And most of them are solving one problem for one company. And since I'm one guy working at a quite small company, I want to be able to do a lot of things with my tools. I want to be able to provide the developers what they need. Also, I want to take care of all the legacy we got. So when we started this journey, we just started with our newest APIs and started to run them in container during development and then during deployment. But we still have all the other stuff. So we still have all the databases, all the queuing systems, the load balancers, the cache layer, everything needs to be managed in some way. When I started at Bloglovin, everything was manually. You went into the SSH into the server and did an update. And you have no idea how your system would behave or how it looked or what was installed, which repository was added, etc. So we choose to use SaltStack, of course. And what that brought us was that we had one tool that we could use for basically everything regarding orchestration, but also doing all the new and fancy stuff with containers. So I'm going to be talking a bit about our different phases. So around last autumn, I think it was, I wrote a blog post on how to do container deploys with Salt. And it's been kind of feels like the standard way how you do it. I've seen a lot of presentations doing exactly that same thing. So that's going to be the phase one, which I'm going to be talking about and showing the state files for that. And then I'm going to go on to thing that we've been like evolving our service to the phase two to do more of a green and blue deploys. Actually put up the whole new clusters of containers, test that they are working, and then killing the old one, putting the new one into the load balancer. If you would go like most of the talks here is regarding AWS, and I would love to use something like that, but with what we got our own servers, and we need to be able to do both things. So how do you go from your developer to committing code to actually put stuff in productions? It's really easy to do the Docker run commands, and all the developers are happy to do that on their local laptops. But how do you do that in production? So I'm going to be showing off our Jenkins stuff as well. So we, as everybody else, is using Jenkins to build the containers. And then also using Jenkins to trigger the deploys, which the deploys then are done with Salt. So I'm going to talk a bit about the setup for these two stages that we're going to be talking about, and how like the architecture is. It's a normal web application stuff. So we have the caching layer, application layer, database, queuing stuff, like you would in any application. And then we have the Salt master, Jenkins master, and nodes. A lot of those. Whoops. And of course also the Docker registry. And most of, right now at Bloglovin, this layer is using Docker and these layers as well. So we're running Jenkins in a container provisioned by Salt. So it's a bit inception over it. So let's start talking about the phase one, which we've actually been running in production very successfully for the last 9 months. It has a couple of drawbacks. Of course, we have no active health checks before we actually continue with the deploy. So we do I'm going to go back to this. So we do one of the, what we call ships, one of the ships each, and each ship is running multiple containers of each service. In our case, we have quite large servers, and then we run a lot of services on each ship. And on each ship, we're doing a rolling deploy of all containers, which means that that ship can always take traffic from the load balancers. So ship will never be down, or can always take traffic. But this comes with a negative part of it. It also means that we are serving different code to different users at the same time. And that would work if you don't change anything within your microservice. But we're using this kind of technique not only for our microservices that are stateless, but also for our more traditional old monolithic applications. And those are going to be sending back the wrong response to users if they have different version of the code running at the same time. But this is how we started out, and all of this is you learn while you go. So how do we build images? Building images and pushing images, it's the same in both these phases. So we're using a Docker file. There's been a lot of discussion lately if the Docker file is fast enough or good enough. It's been working quite good for us. We are actually using the TIN model. The TIN model is when you actually have only running one process inside one container. And to build that container, we're doing a base image, which is basically Ubuntu, adding a couple of troubleshooting tools so that we have the same kind of base in all our different containers. When we've done that, which we usually don't do that often, it's like we do that when a new version of Ubuntu is coming out, or when there is a like shell shock, basically. And then we have the application image, which is basically a Node version, or a PHP, or MySQL, or Elasticsearch. So we run that, we have that image, and then from that image, we're adding our application codes and do running tests. So that means that every time somebody commits, we will actually do application code build. And that will be pretty fast since we already built all the other stuff. We're not going to rebuild that all over again. And then, of course, you got to get those containers off. We're not using Docker Hub, as it's terribly slow if you're in Sweden, and if you're at AWS in Europe too. So we are pushing from Jenkins, we are pushing, wait, this is actually the wrong slide. So we're actually pushing all our images to our local registry, and then on each location we have a local registry mirror, which means when we do deploy in these ships, so say we have 4 ships, it's only going to be pulling the image from our local registry one time, and then it's going to have that mirror for all the other ships, which is really neat. All right, and then we need to get those images down to the actual ships or the minions, and that's where Salt is coming in. So we're using the Salt API from Jenkins. Actually, we've been using both the Salt API and the Salt call, since Jenkins is a minion as well. So first we started with the Salt call, since the API has been kind of, have had a lot of bugs. So we used the Salt call to do a Salt call to target which minions this image should be run on, and tag version, etc. I'm going to show it later. And then those images goes to the local registry to fetch that image. And of course, the last part is that you actually run the containers. So I'm going to be going into a little bit more about the code, actually. So I'm not really sure, can you see this, or is it too small? A bit. All right, all this code is going to be, it's available on GitHub. So I'm going to put up the links afterwards, so you can just get it there. So basically what I usually do in all my state files is that I set all the variables in the top, meaning that I can also, or I think that's an elegant solution to actually go in and you see that you have all your variables at the top, and then you can do all the fancy stuff down there and roll over stuff. One of the things that we are doing is that we're using dynamic pillars, or we are injecting pillars into the Salt call or the Salt API to actually set the Docker image. And the Docker image, in our case, is always the Git tag for that deploy. And then, of course, we pull down the image. You probably, if you used it, it's docker.pull. Its also last version was really buggy, so that we used the CMD run, actually, to do that stuff. But since Helium, it's actually really stable. What we're doing then in this kind of rolling deploy stuff is that we actually check the version running with the new Docker image that we pulled down. Is it the same, or has the image changed? We're only removing and doing a deploy if an image has changed. So we're using the unless on a CMD run. And first we stop the container, and then we remove the container. You can do that in one step, but we are adding the timeout, since our APIs needs to close down all their connections and tell the registry that, or etcd in this case, that they no longer exists. And then we are starting the container. We are running multiple containers on each Docker host. That's why you see all the numbers everywhere. So we're just starting a fixed set of containers on each host. So we say that we want to run 10 containers of this service on this node. It's all really static, but it works good when you have a controlled environment like we do. And then we also start the container. So starting and stopping container, if you're not familiar with Salt doing it, it's not the same as when you do a Docker run on the command line. Salt is doing it in 2 steps, but the Docker run is actually also doing it in 2 steps. It just talks to the Docker daemon sending, and that one is doing 2 steps. Cool, and how then are we starting them? So you could actually start them just by doing a Salt command run as well, which is really neat when you need to troubleshooting things or set up. So what I'm doing is I'm just running a state SLS against our state container, and then adding in the pillars that I need for this deploy. And I think, yeah, so I also have one where we do a webhook. So we're using the Salt API webhooks, which I can really recommend, really neat to work with. You have to set up your own security around them, but otherwise they're really nice to connect outside stuff into the reactor. And the same kind of thing, but doing a Salt call instead. I actually saw now that I don't have anything about the reactor stuff, but I'm going to show that later, since that's probably the most important part. All right, that's fine. We now have kind of rolling deploys. We have actually tested this quite a lot. We do deploys a couple of times a day, sometimes even like a couple of times an hour. And it's working really nice with all our services. So we have around 30 services running this kind of deploy scheme. All right, so let's move on to phase 2. So phase 2 is the more kind of the green and blue deploy stuff. I actually finished up this last night. The Wi-Fi here isn't that good, so I was planning of showing it off, but I'm going to show you the files instead. You will kind of get the point. This version is also on GitHub. So what we're going to do here is that we want to deploy new containers before killing the old ones. On the last version, we actually killed the old ones and then started up a new one. And in our case, that didn't really matter because we had a proxy before it that actually just removed it out of availability before you started up the new one. And then we're going to be using health checks to actually see that the new containers are working. Otherwise, we just do a clean rollback. Or actually, we're not doing the rollback yet. We're just stopping it. And then for this thing, so we are using etcd. It's a key value store for those who doesn't know it, where you can store key values, basically. We're using it extendedly for our APIs. Our APIs, when they are up, they're actually registering themselves in etcd and telling I'm here, so that all the other APIs can talk to that API. So service discovery. And all our APIs are also talking to each other on event bus, basically. So we're using RabbitMQ, and all the APIs are talking to each other on that queue.